We are starting on our guided notes titled Solving One-Step Equations. This is a review from previous years, so Math 6, Math 7, so hopefully this is familiar. If not, that's where we're going through the notes. We're going to go through this and solving two-step equations to help us for the current Carnegie math topic. Anyways, so what is the goal when you solve an equation? The goal of solving an equation is to isolate the variable. Okay. Now we want to isolate the variable to find out the value of that variable. How do we go about doing that? Is we use what's called, we're going to be using operations, but we use what's called is inverse operations. Okay. Right, operations, add, subtract, multiply, and divide. Inverse just means it's the opposite. So an example here is like addition, that is the inverse of subtraction. Multiplication, represented with a dot, that is the opposite or inverse of division. Typically we'll see that in the form of a fraction. All right, and we're trying to find the solution. So a solution is a number that satisfies an equation. Okay, so we're going to go through 4 examples here. Example 1. Solve the equation. It says x minus 9 equal to 11. So the goal here is you're trying to figure out what minus 9 is 11. So I think for a lot of students, maybe you can just determine that. But if not, what's the steps about going through that? So what we're going to do is I'm going to draw a line down the equal sign. The reason I'm doing this here is because you're going to be performing operations. And since this is an equation, we know that the left side, that expression is equal to the right side. So if we do anything to the left side, we also have to do that and replicate that to the right side as well. So we want to get x by itself. So as you can see on this side of the line, we have this minus 9. So how do I get rid of that minus 9? We're going to apply the opposite operation. It's subtracting 9, so we're going to add 9 to both sides. I'm going to add it here. Negative 9 plus 9, this is equal to 0. I'm going to circle it. The circles that we write in an equation represent that it's equal to 0. But we're also going to put that on the right side as well. So when we rewrite this, whenever you rewrite, always put an equal sign. The left side, it was just x. Right side, 11 plus 9 is 20. So this, we're actually done because the variable is isolated. There's nothing else with it. You can think of this as an x or a 1x, but x is equal to 20. So when you rewrite this equation here, we can check our answer. Or I'll put 20. Instead of putting x minus 9 equal to 11, I'll put what x is equal to. 20 minus 9 is equal to 11. That is a true statement, so that tells us that that is the value that satisfies the equation. Okay, so I would say when we go through these types of problems, right, if you ever have more than enough time, let's say we're taking a quiz, taking a test, you still have time, always go through about checking your answer. Next one, we have 4 equal to negative 3 plus a. This negative 3, you could think this as a minus 3. It's separated from the a, but you can think about if I want that a by itself, or how do I go about getting rid of this negative 3? This negative 3 is we're going to add 3 to both sides. We'll circle it here. We know that's equal to 0, negative 3 plus 3. If you owe $3 and have $3, in the end it's going to be a net 0. 4 plus 3 is 7. So here we have 7 equal to a positive a. We'll just write a here. So it turns out that a is the value that makes this equation true. So if I rewrite this, instead of putting 4 equal to negative 3 plus a, we'll put 4 equal to negative 3 plus 7. So is that negative 3 plus 7 that is equal to 4? This is a true statement. Okay, so we're going to practice problems like this for adding and subtracting, how to undo that using inverse operations. But let's go through multiplying and dividing examples 3 and 4. Before we get to these examples, I'm going to look off to the right. The number in front of a letter. The number in front of a letter is called the coefficient. It tells us how many variables we have, the quantity. So in this case, we have 5m. This means 5 times m. So here I'm just going to put that it means to multiply. Okay, so just be mindful of that because since it is multiplication, that tells us what the inverse operation is. So let's go through example 3. The example is -20 equal to 4m. Now this means 4 times m. I'll put a dot for multiplication. We'll put it right in between. But many times I'll see students that will look at this and they'll say, okay, we have a positive 4. Let me subtract 4 to both sides. Well, not quite. You have to ask yourself, what is that 4 doing in relation to the m? It's multiplying. So ask yourself, what's the opposite of multiplying by 4? It is to divide by 4. So how do we write that? To divide by 4, we represent this using fractions. So we'll divide 4 on the right side, and we'll divide 4 on the left side. Now, dividing by 4 on the right side, what's 4 divided by 4? Right, 4 divided by 4 is 1. So what I like to do here is I just cross it off. When you draw circles, like example 2, circles means they add to 0. These lines mean they divide to 1. So on the right side, since it's 1m, 1m is the same thing as saying m, just like how saying 100 is the same thing as 100. Or you have $100 or $100. We don't have that. We don't need to have that 1 in front of the m. Left side, we'll apply our divisibility rules for signs. A negative divided by a positive is a negative. When you're multiplying or dividing, when the signs are different, it is a negative. And 4 can go into 20 5 times. All right, so our final answer here is -5 equal to m. Let's check our answer. All right, we'll rewrite -20 equal to 4m, but instead of m, I'll put -5. We'll put that in parentheses as well. Right, positive times a negative is a negative, and 4 times 5 is -20. We have the same number here. It's equal. This is a true statement. All right, and last one here, we have division represented as a fraction. The way we read this is n divided by -5 equal to -3. So although we see a fraction, it might be somewhat confusing, we can get rid of that fraction, right? Because the way we read this is divided by -5. So just ask yourself, what's the opposite of dividing by -5? Is multiplying. So multiplying -5 to both sides, I'll put a dot here, we'll put -5. I'll put a dot here, and I'll put that as well. Now, when you are multiplying and dividing by the same thing, we just draw a line through it. It just equals 1. But I'm not going to always demonstrate this, but I'll rewrite it here. Right? If you remember when we multiply with fractions, we put a 1 under any whole number. And you can multiply laterally. So -5 times n is -5n. And then the denominator is 1 times -5 is a -5. We can simplify that to be negative divided by negative is a positive. 5 divided by 5 is 1. 1n is the same thing as n. So that's why we just cross it off. All this work that we did off to the left isn't super necessary if you realize what the inverse operation is doing. But we'll just put n off to the left side. On the right side, we can simplify that. Negative times a negative. The signs are the same. It's a positive. And 3 times 5 is 15. Okay. I'll let you check this problem, but our final answer here is n equal to 15.